Hello everyone, welcome to another GCSE chemistry video. If you bear with me, I will just share the screen for you so you can see what today's lesson is about. So the learning question today is, what are the properties of alkali metals? And you've probably heard of these because you will have looked at them at Key Stage 3, but we're going to look at them again. We're going to look at their properties, their reactions, where they are on the periodic table. Okay, so we're going to learn all about the alkali metals. So if you could write the learning question, what are the properties of alkali metals? So the word properties means what are they like? Okay, so what characteristics do they have? All right, so if you pause the video and write the learning question and have a look at the Do It Now, which is a series of revision questions about alkali metals. Well done. So these are the alkali metals listed in their group in the periodic table. So from the smallest element to the largest element. And which group do they all belong to? Well, they've all got one electron in their outer shell. So that means that they are in group 1. What charged ions do they form? Because they've got one electron in their outer shell, when they react, remember when an atom reacts, it wants to gain a full outer shell. So the easiest way for group 1 metals to do that is by losing an electron. So if you lose an electron, you're losing a negative charge, so the atom will become positive. So that's why the charge that they form is +1 or +1, because they lose that one electron from their outer shell when they react. Write the electron configurations for sodium and potassium. Remember, as you go down the group in the periodic table, the atoms, the elements are becoming larger, okay, because they are increasing their number of outer shells. Okay, so sodium would be two electrons in the first shell, 8 electrons in the second shell, and that 1 in the outer shell. Remember, because they're in group 1, they will always have 1 electron in that outermost shell. So that's why the last number is always 1. And explain why all these elements are in the same group. So elements in the same group have the same number of electrons in their outermost shell. So you can see here that these group 1 alkali metals all have 1 electron in that outermost shell, meaning that they are all in group 1. Okay, so if you need to pause the video and just write down any notes about that, then you can do that now. So if you're looking at the periodic table, remember all the group numbers are at the top here, so 1 through to 0 or 8. And group 1 is this first group over here. So right here on this left-hand side. Okay, so that's where group 1 is. So what I would like you to do in a moment is pause the video and copy out this table. We are going to look at the 3 most common alkali metals, and these are the ones that you're most likely to be asked questions about in your GCSE exams. So we're going to have a look at a video in a moment that shows the reaction of lithium, sodium and potassium in water. So you are going to, in a moment after you've paused and copied out this table, you're going to describe the appearance of these elements. So what are they like? What do they look like? What do they look like when they're cut into? So that's just kind of describing what they look like. And you're going to describe your observations, so what you see when that element is put into water, reacts with water. Okay, so pause the video now, sketch out this table, and then we're ready to watch the video. Okay, well done. So here we go. So you can see all of the three alkali metals that they're showing us at the moment are darker around the outside, and when you cut into them they're more shiny inside. Now that's because the outside of them has already reacted with the water that's in the air, the water vapor that's in the air, so that's why they've got that kind of tarnished look, and inside you've got the metal, the pure metal that hasn't reacted with water yet. That's why they're very shiny inside and quite dull around the outside. They're quite soft, aren't they? They're fairly easy to cut into. So this is sodium. Let me double check. No, this is lithium. So they're doing the smallest atom, lithium, and let's have a look at its reaction with water. So for lithium, I would describe my observations of the reaction would be that it produces a gas, so it bubbles, it's moving around the tank. Okay, so I'd pop that into my table. So this is sodium. So I would say that this reaction is a bit more vigorous. Okay, it's reacting a bit faster, it's moving around faster, it's producing some steam. Yeah, so the reaction must be happening at a greater rate. So this is potassium, and potassium is the coolest one, and if you've seen it in school, you know, you've all had to stand back because it does burst into flames. So let's watch that again. So to describe my observations for that reaction, so when you put potassium in water, it sparks, it produces a flame, it moves around very quickly. So it's a very fast, very vigorous reaction. So now what he's done is he's taken a sample of the water that's been left behind after the reactions, and he's put it into a test tube. So he's used a pipette to get a small sample of it. He's put it into a test tube. And he is adding universal indicator. So he wants to see what the pH of that water that's left behind is. And you can see it's going this purpley colour, which means that it has an alkali pH. There we go, so quite a strong alkali pH, probably a pH of about 13, 14. So that's why they're called the alkali metals, because when they react, they turn the water alkali. There we go. Okay, so if you need a moment to go back and look at that video again, and just complete your observations in your table, then you can pause the video and do that. There's plenty of videos of people reacting alkali metals in water, because it's quite a cool reaction. So if you want to go away and have a look at more videos, then that's fine as well. Okay, what I'd like you to do now is use your observations just to answer these 4 questions. All right, so firstly, use your observations to put the metals in order of their reactivity. So which one had the quickest reaction? Yeah, it was potassium. So potassium would be the highest reactivity. The second most reactive was sodium, so that's one that moved around a bit more quickly but didn't burst into a massive flame like potassium did. And the lowest in order of reactivity was the lithium. Yeah, that kind of just fizzed a bit and moved around pretty slowly, didn't it? Okay, why did you put them in this order? Because from watching the video, our observations showed that potassium burst into flame and sparked, whereas sodium just moved around quite quickly, and lithium moved around fairly slowly and just fizzed a bit. So you could just describe your observations a bit there. The gas that was produced was hydrogen. Okay, so you know we saw all of them bubbling and fizzing and producing a gas. That gas is hydrogen. What type of solution is formed from the reaction of alkali metals with water? And how do you know? So can you remember what the scientists did in the investigation to find out what type of solution was formed? Yeah. So remember, it was an alkali solution. So that's the answer they're looking for there. And how you know is because if you take a sample of it, a sample of the water, and add a couple of drops of universal indicator to it, it will go that deep bluey purple colour, indicating that it's an alkali solution that's been formed. Okay, well done. So mark your answers for that. And if you need to correct any or write any notes, then you can pause the video and do that now. So this table is looking at the atomic number of these alkali metals and their melting point. So you've got a table here that shows you the atomic number. Now we know as we go down the group, the atomic number increases, doesn't it? Because as you go down the group, more periods are added to the atom. So the period number increases and more electron shells are added. So the atom is getting larger. So you've got the atomic number increasing here. What can you see happening to the melting point? So how does the melting point change as you go down group 1? So if you want to pause the video and write down an answer for that from looking at the table. Well done. So hopefully you will notice that as you go down the group and the atomic number increases, the melting point decreases. Well done. What state are all these elements likely to exist in at room temperature? So looking at their melting points, what do you think they would be at room temperature? So pause the video and have a guess at that now, please. Well done. Yep, they're all likely to be a solid. Yeah, because room temperature is usually lower than all these temperatures. So for that reason, these elements were likely to exist in solid form. All of these melting points, they're quite low compared to other metals though. How does the size of the atom change as you go down the group? What's happening to the size of the atom? Well done. Hopefully you've noticed that the size of the atom increases, the atomic number increases because more electron shells are being added. And can you describe how the size of the atom changes with the melting point? Okay, so just a short sentence to describe that trend. Pause the video, see if you can write a short sentence to describe that relationship between the size of the atom and the melting point. Well done. As the size of the atom increases, that's this part here, so size of the atom increases, the melting point decreases. Fab, well done. So mark your answers for those. Just pause the video if you need to. Well done. So that was looking at some of the physical properties and some of the properties in terms of reactions. Now we're going to look at some more of the chemical properties of alkali metals. So this is the equation when any of the alkali metals react with water. So you add the metal to water and you get a metal hydroxide and hydrogen. So remember, hydrogen gas is what's forming in those bubbles that you can see when the alkali metal's kind of fizzing around on the water. So that's a general equation. So that's worth writing down. So if you just take a moment to pause and write that general equation down. Well done. So here's an example. So if you add lithium to water, you get lithium hydroxide and hydrogen. Can you now, using that general equation and using the example of lithium, can you write out the reaction for sodium plus water and potassium plus water? And there's some equation balancing there if you're feeling very confident. Well done. Okay, so now we're going to look at an explanation of why the reactivity increases as you go down the group. So if you remind yourself of your table, lithium was the least reactive, sodium is in the middle, and as you went down the group and got to potassium, it became very reactive. So we're going to look at an explanation of why that is the case. So remember, all alkali metals have got one electron in their outer shell. So here is sodium, you can see one electron in the outer shell. Here's potassium, one electron in the outer shell. Now when an alkali metal reacts, it loses that outermost electron. So that outer shell electron is what we call donated. Okay, so you lose it. To begin with, these negatively charged electrons are held in the shell by the pull of the nucleus. So the nucleus has a positive charge. That outermost electron has a negative charge. So that's what holds the electron in place. When the alkali metal then reacts, that outermost electron is lost. Okay? As the atom gets larger, so as you add more shells to the atom, the distance between the nucleus and that outermost electrons gets bigger. So you can see here, the distance between the potassium nucleus and the outermost electron is much bigger than the distance between the sodium nucleus and the outermost electron. Yeah, so as you go down the group, the distance between the nucleus and that outermost electron gets bigger because you're adding more shells. So as the atom gets bigger, its hold, so the hold that it has, the pull that it has on that outermost electron gets weaker. Yeah, so as that electron gets further and further away, as you go down the group, the pull gets weaker and weaker. So that means that the bigger the atom is, the more reactive it is, because the easier it can lose that outermost electron. Okay, so hopefully that made some sense. That's quite a difficult concept and quite a difficult explanation to grasp. So if you need to pause the video and go back and listen to me explain that again, or you can go onto BBC Bitesize and look up the explanation for the trend in reactivity of alkali metals. But the most important point that you need to remember is that as the distance between the nucleus and the outer electron increases, the metal will get more reactive. So as you go down the group, the distance between that nucleus and the outermost electron increases, and the reactivity also increases. Okay, that's the most important point. Okay, well done for listening to today's lesson. There's been some tricky concepts in it. And what I'm going to leave you with is 2 exam style questions. Now they're both worth 2 marks, and you can either answer them yourself on paper or you can submit them to Shobi at www.shobi.com using this class code here, and myself or another science teacher will mark them for you. Okay, so the first question, state 2 properties of alkali metals. And question number 2, explain the reactivity of alkali metals. And if you need to go back and watch the video again or need to go on BBC Bitesize, then you are welcome to do that. Okay, right, hope you have a lovely week and hope you're all well. We miss you lots, so goodbye from the science department and myself.